In this video, I will cover adding, subtracting, and simplifying cube roots. I have another video on simplifying, adding, subtracting, and multiplying square roots as well. So for our first example, we'll do the cube root of 5 plus 8 times the cube root of 5. Now since this is a cube root of 5 and this is a cube root of 5, we can add these together. This is really 1 cube root of 5 plus 8 cube root of 5 to give us a total of 9 times the cube root of 5. You can really treat cube root of 5 like an x. If this was x and this was x, 1x plus 8x would be 9x. For our second example, we have 7 cube root of 5 minus 11 cube root of 5. So again, we can subtract 7 minus 11, and that will give us how many cube roots of 5 that we have. So we have negative 4 cube root of 5, and that is our final answer. Now I'll go over several examples on simplifying, and then I'll come back to adding and subtracting along with simplifying. We'll simplify so that we have the same radicand, meaning the same number under the radical, and they'll both be cube root. So let's do some examples on simplifying. Let's simplify the cube root of 24. Now in order to simplify cube roots, it's really handy to have a list of your perfect cubes. So let's do that first. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. Now, of course, we could keep going, but these are the ones that we're going to be using today. So when we're looking to simplify the cube root of 24, we really want to see which one of these perfect cubes is 24 divisible by. So 24 is divisible by 8. So we can break this up into the cube root of 8 times the cube root of 3, since 8 times 3 is 24. And we know that the cube root of 8 is 2 because 2 cubed is 8. So we can simplify this to 2 times the cube root of 3. And that is our final answer because we cannot simplify the cube root of 3. So we're gonna leave all of these in exact form. We're not gonna put any of this in our calculator and get a decimal. When it says simplify, it usually does want this exact form with the radical left in the answer, just simplified as much as possible, which means take out the largest cube that you can. So let's look at another example. Let's do the cube root of 54. Now, you may need a calculator when you're doing these, and you can divide 54 by 8, and that is not divisible by 8 because you'd get a decimal, but it is divisible by 27. If you divide 54 by 27, you get 2. So you can break this apart into the cube root of 27 times the cube root of 2. And then we know the cube root of 27 is 3, and we cannot simplify the cube root of 2 any further, and so that is our final answer. Let's look at the cube root of negative 8. The cube root of negative 8 is negative 2 because negative 2 times negative 2 times negative 2 is negative 8. So there is a number that times itself 3 times is negative 8. A negative times a negative is a positive, times a negative again is a negative. So unlike square roots, where you cannot take the square root of a negative number to get a real number, it would be imaginary, and I explain that in my other video on square roots. We can take the cube root of negative numbers, and we always want to take that negative out. That is in simplest form. So let's look at another example with a negative radicand, a negative underneath a radical, negative 500. So 500 is not a perfect cube. So which one of these perfect cubes is 500 divisible by? You may need a calculator, but 125 would be a really good guess since it ends in a 5 and this number ends in a 0, that 500 would be divisible by 125. And it is, and so you can break it down into the cube root of negative 125 times the cube root of 4, since 125 times 4 is 500. And the cube root of negative 125 is negative 5, and we cannot simplify the cube root of 4 anymore, so that is our final answer. So we definitely, when we have a negative under the cube root, we really want to take that out. That's in simplest form. And if you wanted to, you could split it up, but there's no reason to do that right now. But you could have split it up into the cube root of negative 1 times the cube root of 125 times the cube root of 4. Because the cube root of negative 1 is negative 1. But let's just put it with the number, since we know negative 5 times negative 5 times negative 5 would be negative 125. Let's do the cube root of 875. Which of these perfect cubes do you think 875 is divisible by? Go ahead and pause the video and then check your answer. So 875 is divisible by 125. When you divide 875 by 125, you get 7. So it's 125 times 7. The cube root of 125 is 5, and then you leave the cube root of 7. Let's do another example where we have a number out front of our cube root. So we're going to do the same thing here. We're going to look for that biggest perfect cube that 192 is divisible by. So go ahead and pause the video and figure out which number you can divide 192 by. And then we're going to leave this 2 out front, and we're going to split this up like we usually do. So hopefully you found that negative 64 is the biggest perfect cube that 192 is divisible by. And so the cube root of negative 64 is negative 4. And then we just multiply this number that we got from here times the number that's in front here. So you just multiply these, so we get negative 8 times the cube root of 3. And that's our final answer. Now let's look at what happens when we take cube roots with variables, and then we'll do numbers and variables together. So the cube root of x cubed is x. Now if you watch my video on square roots, you know that the square root of x squared is really the absolute value of x, because we want to make sure that it comes out positive. But here we can take the cube root of negative numbers, and so this really is just x. Now, when we take the cube root of x to the 6th power, if you watched the video on square roots, then you know that the shortcut is that you can just divide this exponent by the index here, the number that is of the root that you're taking. So this will come out to be x squared. But let me just explain it a little bit more. If you haven't watched that other video, then you can look at this as 6 x's multiplied together. That's x to the 6th. And so since we're taking the cube root, we need to find triples. And there's 2 triples. So it's basically the cube root of x cubed times the cube root of x cubed. So we know the cube root of x cubed is x. We know the cube root of x cubed is x again. And then we have x times x, which is x squared. But you really want to use this shortcut that you can divide this exponent by this number here to get your answer, because that is just a much faster way than having to write it all out and look for the triples. Now, if you're taking the cube root of x to an exponent that is not a multiple of 3, what you want to do is you want to find the closest but lower multiple of 3 and then put any extra x's in another radical. So we know that the closest multiple of 3 under 7 is 6. But then we still have the cube root of x, because x to the 6th times x to the 1st, we don't really write the first power, but this is to the 1st power, is x to the 7th. So we can always split up our cube root. So we're really getting a perfect cube here, and then having our leftovers in this one, just like you do with numbers. And so this is x squared, and then we still have the cube root of x left, and that is our final answer. So what if we have more than one variable? Let's take the cube root of negative x to the 14th times y to the 9th. So we probably just want to write the cube root of negative 1, since we have no other number here, but we know this is negative 1. So let's just get that separated here. And then, what is the closest but lower multiple of 3 in 14? 12. So we'll take the cube root of x to the 12th, which means that we still have 2 x's left over for our exponent of 14. That would be 12 plus 2. So x to the 14th, we have x to the 12th times x squared. Now 9 is a multiple of 3, so we don't have to split that up. We can leave that as a cube root of y to the 9. And then we can simplify everything. So the cube root of negative 1 is negative 1. The cube root of x to the 12th is x to the 4th, because we just did 12 divided by 3. We have 4 triples inside x to the 12th. The cube root of x squared we cannot simplify. The cube root of y to the 9th is y to the 3rd. Now in standard form, we would write everything that we took out of the radical and then the radical last. So we'll rewrite this. So we'll take our negative 1 and then our x to the 4th times y to the 3rd, and then we'll multiply that times the cube root of x squared for our final answer. Now let's do another example where we have a number in the front of the radical, we have a number inside the radical, and 2 different variables. We'll do 2 times the cube root of 432 times m to the 28 times n to the 11th. So we'll leave that 2 out front, and then we'll split up the cube root of 432. Go ahead and pause the video and figure that out. You have the cube root of 216 times the cube root of 2. Since 216 times 2 is 432, and 216, the cube root of 216 is 6. Now what is the closest exponent that's a multiple of 3 that's less than 28? And then how many do you have left? You have the cube root of m to the 27th times the cube root of m. You have one m left over since you wanted 28, so 27 plus 1 is 28. And then what about the n to the 11? 9 is the closest multiple of 3, and then you have 2 left for 11, for a total of 11. So now let's simplify everything. So the cube root of 216 is 6. We will leave the cube root of 2 as it is. The cube root of m to the 27th is m to the 9th. We'll still have the cube root of m. The cube root of n to the 9th is n to the 3rd, and we'll still have the cube root of n squared. Now to write this in standard form, we'll do the 2 times 6 for 12, and we'll multiply by m to the 9th and n to the 3rd, and then we'll have one cube root where we'll multiply everything that's left under the cube roots, the 2, the m, and the n squared. So we have 12 times m to the 9th times n to the 3rd times the cube root of 2 times m times n squared. And that is our final answer. Now, let's do 2 more examples where we add and subtract with simplifying. In this example, we cannot add the 5 and 7 right now because we have different radicands. We have a 48 here and 162 here. So first we have to simplify until we get the same radicand, and then we can add what's in the front together. So look for the greatest perfect cube inside 48, and that would be 8. 8 times 6 is 48. And look for the biggest perfect cube in 162. That would be 27. 27 times 6 is 162. Now, you already know when you're at this point that you're on the right track because you know that you can simplify this to 2, and you know you can simplify this to 3, and then you're going to have the cube root of 6 here and the cube root of 6 here. And since these are going to be the same, then you're going to be able to add what's in front together. So we know that the cube root of 8 is 2. We know that the cube root of 27 is 3. And since these are multiplied together, then we'll do 5 times 2. We'll do 7 times 3. So we have 10 times the cube root of 6 plus 21 times the cube root of 6. And now we can add the 10 and 21 together and get 31 times the cube root of 6. And that is our final answer. Let's do another one. We know that we cannot subtract right now because we have different radicands. We have 108 and 256. So let's look for the perfect cubes that these numbers are divisible by. A 108 divided by 27 is 4. 256 divided by 64 is 4. So again, you know that you're on the right track with these because if you know that you can simplify this, and then you have the cube root of 4 here, cube root of 4 here, then you know you're on the right track. So the cube root of 27 is 3. The cube root of 64 is 4. 11 times 3 is 33. 10 times 4 is 40. Now we can subtract. Since we have the cube root of 4 on both terms, 33 minus 40 is negative 7 times the cube root of 4, and that is our final answer. I hope you've enjoyed this video. Please like, subscribe, and comment, and check out my other videos.